quote, "If an element is removed from its natural place, it tends to return to that place by a straight line movement." Now, so things move of their own accord, naturally, and there's no question of where the stuff comes from, the movement, the impetus, and so on. It's just natural. It just happens. That's the way it is. They couldn't take a step back from it and explain all movement as such. They had to explain this type of movement and that type of movement, the natural and the violent, which we were speaking about a bit earlier. But to expand the thought now, on the moon, the sun, the planets, quote, "Here the laws of movement and the nature of the constituent elements differ from those in the sublunar world." Okay, that's how they didn't have very much evidence. You've got to let the Greeks off the hook a little bit. They're talking about energy and movement and energy input here on Earth, and energy and movement and energy input out there in the stars as being completely separate and different things. Now, Newton, you may know, got where he got to by studying the motions of the moon. That's where he first proved his theory of gravity. So, very, very different from the Greeks, who said not only is there violent and non-violent motion here on the Earth, but there's sublunar, meaning underneath the moon, subluna meaning Greek for moon, sublunar types of motion, and then terrestrial motions, the stuff up in heaven. They have 4 different types of motions, or 3 there, I guess. There's violent, non-violent on the Earth, terrestrial, celestial, I don't know, maybe that's 4. All very confused, and the fact is there's one type of movement or energy, mass, force, only one, to be talked about with all of it. Now they had to explain it this way because the planets just keep moving in circles, and let's see if I should give that quote real quick. "Unlike sublunar rectilinear movement, the circular movement of the celestial bodies does not require the continued presence of substantial contact of both force and resistance." So, stuff up in the heavens is different. You don't have to be putting force into that all the time, but stuff down here is... And as long as they were bifurcating like that, they could never get to the next step. Now we're going to go to the Scientific Revolution, 1500 to 1800, by A.R. Hall. Just a quick quote here. "The unity of learning, which the 16th century inherited from the Middle Ages, is a strong mark of its diffusion. Scientific knowledge, in particular, showed little differentiation in pattern, though it varied greatly in quality and method, because it was not the native product of Christian civilization in Europe, but imposed upon it." So there weren't differences in scientific views and stuff throughout Europe. Pretty much basic scientific views throughout all of Europe were the same because they didn't come up with it. They got it from, quote, the primitive Germanic tribes had long submitted to Romano-Hellenistic culture. They got it from Rome and Hellas, or Greece. So, when we get clear up into the 1500s, and we have Copernicus now, and Galileo's coming along, you're still dealing with these old concepts of Aristotle and the Greeks at the very, very best. Or people who were even more ignorant than that and hadn't even really thought about these subjects at all, which might even be a benefit to them in this case, because the Greeks were so confused. Now we've seen again and again that they are separating things and giving concepts to things that ought to be united. So I want to talk now about Newton, Galileo, and Einstein very briefly, to show the proper method and to show how we got where we are today compared to the mistakes the Greeks were making by bifurcating everything the way they had to, the way they did. Let's take Isaac Newton. He sees an apple fall from a tree. I don't know if he really did. He sees the moon going around the earth in circles, but not falling. And instead of saying there are 2 types of motion, he says this is one and the same thing going on here. The apple falling and hitting the ground, and the moon circling the earth is the exact same thing. Okay? So this is the work of science. The work of science is to put together disparate facts which belong together. For example, Benjamin Franklin. Let's do that real quick. I don't have that put down here, but there's another instance of somebody who took this fact and that fact, put them together. He said they're not different. They're the same. Everybody wants to look at each thing in the world and look at it alone, and later on you have to start putting them together, and the work of science is that putting together, is the uniting of ideas and concepts. Science is saying there's no difference between these. This is all the same. Group this, these are all the same. Group these things, they're the same. That's science. Newton saw the apple and the moon as the same thing. Galileo saw a thing setting there that you have to now push, and a thing moving that you have to now stop as the same question. Namely, inertia, or the resistance to change in motion. Galileo said, if you got something that's moving at a certain speed and you want to turn it one way or the other, slow it down or speed up, you're going to have to put more energy into it. And something that's setting still, likewise, if you're going to move it, you're going to have to put energy into it. There's no difference between something that's moving and something that's holding still. The thing that unites them, the thing that's similar in both cases, the thing that's similar is inertia, the resistance to change in motion. Einstein said, here we have mass and we have energy around, and they're not different. He used let's see, I didn't have this in my notes, I wasn't planning on saying this, but the scientists were trying to explain all the energy coming from the sun throughout the 1800s, and they had all, chemical reaction stuff. They hypothesized maybe it's made out of coal. No, it'd have to be much, much larger. It could be made out of this, could be made out of that. What is it burning? They finally had to come up with nuclear, the theory of nuclear fission, and that isn't even proven. We don't even know for sure. We haven't gone to the center of the sun to find it. But there's sure a lot of evidence for it, including all the elements in the universe. So there's tons and tons of energy coming from somewhere, and where could it be coming from? And Einstein said energy is locked up in matter, in mass, and to get the energy out you have to break the mass apart, and that's called a nuclear explosion if you get a chain reaction that's self-sustaining, a self-sustaining chain reaction. So here, again, we have Einstein saying there's no difference between these things. You can't say there's energy on the one hand and mass on the other. Energy is equal to mass plus a couple of, if you multiply it a little bit. And that's equivalent. There's no difference between them. So, I think that's all I can do for now on that, especially without all my books in that I had in Utah. The salient quote, now I'll end with that. The salient quote from Isaac Newton, which I think was from James Gleick's book, G-L-E-I-C-K, I think. I don't even know if that's the right name. But Newton was very impatient with some of the other thinkers of the day, who, like what's the guy? Descartes, who was either a contemporary or before. Maybe Descartes came after. I don't know off the top of my head, but these other thinkers who Newton was, oh no, Mr. Green, it might have been a guy in the scientific get-together hubbub of London. Whoever it was, there was this guy who was writing letters back and forth with Newton, and he would use the term mass without really for being certain what he's saying. He would use the term motion and energy and change and these things, and they were wishy-washy. He hadn't tied down exactly what he was saying and exactly what he meant, and Newton was very impatient with this sort of thing, and he thought that you should only use words correctly defined. Now, these words had been around. This is the